Automobiles are incredibly complex machines, and it's easy to get it wrong and have little problems. But it takes something special to create truly an automotive engineering disaster. And today, I've combined 7 of my favorites from the past. So stay tuned. All right, welcome back, my friends, to All Cars. I'm John, and I love autos. I think you know that. I think about it all the time, and it's really frustrating to hear about when things go really, really wrong, although it's kind of fun as well. I heard many, many years ago that designing a new car is the equivalent of the United States going to the moon. It's that complex. So the fact that automakers can design new cars every 4 years and have them be as reliable as they are is really kind of amazing. But along the way, things go really wrong, and you get the, well, dramatic results, which live in history. So today I've combined 7 of my favorite, and I ask you, participate. Leave a comment below. If I missed something, if you've got a favorite, let me know. But I'm going to start with, Britain, because I don't talk about Europe or Britain or the Chinese market very much on my channel because I don't live there and I don't have a lot of experience with those cars. And when I've been alive, the British didn't really sell cars over here, but it is hard to come up with a list of terrible engineering automotive failures in the world and not talk about the British motor industry. Number 1 is very generally Lucas Electronics. Now, Britain is famous for a lot of things in their automotive world, right? It's haphazard construction, labor actions and strikes and slowdowns, and iffy electronics. I had a very good friend of mine when I was a teenager, and he's still a good friend of mine. He had a Triumph Spitfire, and he used to joke that the headlights had 3 settings: off, dim, and flicker. And I was reading something yesterday, as a matter of fact, that the Triumph Spitfire, when it was introduced, had 4 fuses for the whole car. And apparently the headlights didn't even have one. So Lucas, and I don't want to focus just on them, but Lucas, they have a reputation of building really bad electronics. And the problem is, the British motor industry still has a reputation for iffy electronics. It's hard to go find a review of a Land Rover or a Jaguar where they don't have a problem with the infotainment and they have to turn the car off and back on, where something funny happens, electrical or related. They actually have to mention when a car they have doesn't have an electrical problem. This is endemic, and for some reason, after 60 years, the British motor industry has not figured out that they should really just go hire a couple of Japanese electrical engineers to fix the problem. So I'm going to stick with the British motor industry, and I want to talk about the Triumph Stag, the V8 in the Triumph Stag. Now, I think this is a really good-looking car, but it ended up being a flop. Go check out the other channel, Big Car. They did a really good piece on the Stag, and it was really, really informative. But what's interesting is that the British motor industry, as it was consolidating, they already had a V8, or they were already working on a V8, but Triumph was working on one too, and the British industry was so dysfunctional, Triumph got to develop their own while they already had one over here. And unfortunately, what they developed was one that was very, very, and famously unreliable. Now, as I understand it, what they did was they put the water pump near the top of the engine. So as pressure built up, it released pressure, but that released water. That allowed the water level to drop. So when the engine cooled and you started up again, it never circulated the water properly. Oversimplified, I get it, but the simple dysfunctional fact that they had an engine, they were developing another engine, and they couldn't stop a division from developing an engine that ended up being ruinous along the way. Number 5, Jaguar Nikasil linings. So Jaguar knew they needed to replace one of their old, very, very old engines, and they started to design a brand new V8. And they wanted to make it aluminum to reduce the weight. But aluminum it wears out really easily. It's soft, it scores, and you end up with a lot of oil burning problems and things like that. And so you have to line the cylinder. Well, you could just put in an iron lining, but Jaguar realized that race cars and motorcycles could use something called Nikasil. Now, this is a compound that is electrolytically adhered to the metal, and it provides that lining surface. Used successfully before, Jaguar thought they were on with something, and they designed this wonderful engine. Unfortunately, almost immediately, they began to have weird reports coming in that cars started to start slower, and then eventually just wouldn't start. And what they discovered was so basic. And you're going to see this over and over again in these, that testing, even when you do it, it's so complex to make sure you get it right, if you're even bothering to do basic testing along the way. Jaguar actually tested it. But Britain has very good fuel, but the amount of sulfur in gasoline varies around the world. And what happens is that when the sulfur gets in, it actually mixes and creates battery acid. And guess what it does? It eats the lining of the cylinder. But you might ask, if you're on your ball today, why do motorcycles and race cars still use the lining? Well, because those work at much higher compressions and much higher heats, and it prevents the creation of the sulfuric acid. But this big V8, relatively cooler, allowed sulfuric acid to be created within the engine, ate the linings away very, very quickly. Jaguar switched to an iron cylinder lining, and the problem went away, but the damage was done. I mention it because it's another example of bad testing procedures missing something along the way. You're going to see more of this in a minute. Next up, back to America, we've got to pick on the Oldmobile Diesel. Now, in the 70s, gas prices went crazy, and GM thought the move to diesel was the way to go. You just get more power and better fuel efficiency out of it. And so Oldsmobile developed a series of engines that ran on diesel from like 77, 78, something like that. And they sold them into the mid 80s-ish. And I think in 81, if I remember correctly, Oldsmobile actually sold 60% of all the diesels for passenger cars sold in America. It was relatively successful. The problem is Oldsmobile took a gasoline engine and modified it for diesel. Now, if you know anything about engines, you know that diesels work at much, much higher thresholds, much higher compression. And Oldsmobile engineers knew this too, and they strengthened the block. But what they didn't do is modify the connection or the spacing between the block and the head gasket. So what happened is you had these cylinders compressing the air so much harder, and it literally blew the heads off. It was rampantly unreliable, and although they worked on it and they tried to fix it, eventually it soured Americans on diesel engines. You will still meet people who will be like, oh yeah, the Oldsmobile Diesel. All the other diesels that have lasted for hundreds of thousands of miles, like from Mercedes, we forget about those because the Oldsmobile Diesel was just such a disaster. Next, guess what? It's General Motors again, and it is the Cadillac 864 engine. Now, again, fuel prices were going up, and General Motors was desperately looking for a way to improve their corporate fuel economy. And they came up with this idea, they worked with another company, and they came up with this idea of cylinder deactivation applied to one of their V8s. And what happened is when you were accelerating, all 8 cylinders would fire, but as you reached, say, a cruising speed, it would shut off 2 cylinders or it would shut off 4 cylinders.
As you start out, all 8 cylinders are in operation. As power needs lessen, the car automatically goes to 6 cylinders and then to 4 cylinders. When you need it, it instantly reverts to 8 cylinders again.
So say on the highway, very straight and level, you might only be running at a 4-cylinder level. The problem is the early 80s electronics and processing power couldn't keep up with the system. Now, it was revolutionary. I mention it because it was revolutionary. It was an engineering moonshot. And I actually appreciate that GM tried to do it. But GM eventually abandoned it. And while cylinder deactivation today is very common, you can see it in many different cars, the electronics and the use of hydraulics versus solenoids to disconnect parts of the engine are much more reliable and faster than they were. This was an idea that was ahead of its time. And me personally, I wonder how this made it to market. Did the testing procedures, were they just so bad that GM never noticed it? Or did they notice it and decide to release it to consumers anyway? I know what I think, but it ended up being another disaster for General Motors. All right, so we're coming up on number 1. Be sure to stay tuned afterwards because I've got an honorable mention and it's actually not American or British. But my number 1 is the Northstar system. Now, I've done a whole video about the Northstar system, and I have said a few times on this channel, I think the Northstar was a good engine. Yes, I said it. It is only after it was on the market and after some of these cars started to reach about 100,000 miles that we started to know about the head gasket, well, the head bolt issue, and people started to see just how expensive the repairs were going to be on this car. But when General Motors decided to produce a totally modern engine at the late 80s, early 90s to compete with the Germans and with what Lexus was going to be doing, they again aimed for the moon and put their engineering resources behind it. Engineering was headed up by Oldsmobile. Yes, the same people that brought us that diesel a while ago. And they developed a marvelous, wonderful, smooth, powerful, torquey, gutsy, fully modern overhead cam V8 that was tied in with other systems for the suspension and the brakes. When you drove those cars brand new, because I drove a brand new STS when it came out, it was marvelous, and I really thought it was as good as anything else out there, at least in terms of how it felt. Years later, we know it's one of the most unreliable engines of, let's say, the 90s, and you can watch videos of people online, certainly like on Car Trek, where they pick up an old Cadillac with a Northstar, and you can actually watch it fail while they're driving it.
That's the smell of a Northstar going supernova. That's what that smell is.
That is a very strong smell of coolant, yes.
It was a moonshot. It was a massive engineering undertaking. It took them so long to develop this engine, and they missed something as basic as whether the bolts would hold the head on in the event the engine got a little hot. This is basic engineering testing, and somehow they missed it, and then they were slow to address it as well. My big feeling here, and why I put this as number 1, is because it should have been marvelous. It should have been a world-class engine, transmission, and other systems. But GM dropped the ball and missed something like the bolt length and how coarse the threads were. And keep in mind, in the amount of time it took General Motors to develop an engine that became notoriously unreliable, Toyota developed the entire Lexus platform, LS400, including an engine and a transmission, a car that went on to be legendary for its reliability. And that brings me finally to the honorable mention. This one is really specific, and it is a Mazda. And I hesitated to put this in because this kind of opens up a can of worms, guys. This is, you could start to pick apart little tiny things like the Chevy I had where the oil pan had the starter on top of it so you couldn't actually see it. It opens up those kind of things, but this one absolutely blew my mind. The old RX, the fuel filter. If you look at this picture I found online, the fuel filter was above the rear suspension. Now, fuel filter is a maintenance item, but you have to disassemble part of the rear suspension to access the fuel filter. Now, It's a little different than everything else on here, and I mention it because what happens is it ends up being expensive, and owners just don't do it. And so all of a sudden, you have a car that's failing because of one part back in the back that's about, I don't know, that big, something like that. What a ridiculous design. And I throw it out here just because it really bothered me and I just discovered it. So let me know your thoughts below, guys. What are your biggest automotive engineering fails? Leave me a comment below. Let me know. Be sure to like this video and be sure to subscribe if you haven't. Thanks.